Good day everyone. In this video, we're going to learn about the complexity of algorithm. But first, let us define algorithm. Algorithm is a finite step-by-step list of well-defined instructions used for solving a particular problem. So when we say complexity of algorithm, we talks about the amount of time and space required by an algorithm to run and execute. Time complexity of an algorithm quantifies the amount of time, while space complexity of an algorithm quantifies the amount of space or memory. Time and space complexity depends on lots of things like hardware, operating system, processors, and etc. However, we don't consider any of these factors while analyzing the algorithm. In this video, we're only gonna talk about the space complexity and how to calculate the space complexity of an algorithm. Whenever an algorithm to a problem is written, some memory is required to complete, and algorithm uses memory space for three reasons. First is the instruction space. It is the memory used to save the compiled version of instructions. Next is the environmental stack, space for an algorithm and instructions that is waiting to be called for execution. For example, is a function. And lastly, data space. It is the amount of space that is used by variables and constants. But while calculating the space complexity of any algorithm, we usually consider only data space and we neglect the instruction space and environmental stack.
For calculating the space complexity, we need to know the value of memory used by different types of data type variables, which generally varies for different operating systems. But the method for calculating the space complexity remains the same. Here is a table which shows the equivalent size in byte or bytes of a particular data type. Bool, character, unsigned character, signed character, and integer 8 is equal to the size of 1 byte. Integer 16, short, unsigned short, W character underscore T, and underscore W character underscore T is equal to the size of 2 bytes. Float, integer 32, integer, unsigned integer, long, and unsigned long is equal to the size of 4 bytes. Lastly, double, integer 64, long double, and long long is equal to the size of 8 bytes. Now, let's learn how to compute space complexity by taking a few examples. In the above expression, variables a, b, c, and z are all integer types. Hence, they will take up to 4 bytes each. So, the total memory requirement will be 4 times 4 plus 4 is equal to 20 bytes. This additional 4 bytes is for the return value. Let's have another example, this time a bit complex one. As shown in the example code, it uses 3 integer variables, I, x, and n, plus integer array with 20 maximum length. 3 integer variables times 4 is equal to 12 plus 20 integer array times 4 is equal to 80. 12 plus 80 is equal to 92.
So that's it for this tutorial about the complexity of algorithms. Thank you all for watching.